Travelers make $1,000 booking decisions based on hotel reviews. Those reviews are broken. We built WayWise to fix them, not with more questions, but with the right ones chosen by math. Expedia's own data, 6,000 reviews across 13 properties, 29% of them have zero text. 1 in 3 guests just taps a star and leaves. 8 of 14 rating dimensions have never been filled in. And around the average review is 160 characters, and 92% of hotels have no information in their own listing. This platform is just collecting numbers and not insights. An obvious solution would be to just throw all the reviews at an LLM and prompt it as to what to ask the user. But we ran the numbers. Take an LLM like GPT-4o, where we would require around 16,000 tokens per request. That amounts to around 4 cents per review. At 1 million reviews a month, that's $43,000 every month just to pick a question for the user. WayWise does this completely differently. Math happens offline and the LLM just talks. 13 hundredths of a cent per review. Yes, $130 a month versus $43,000. That's 330 times cheaper and 15 times faster.
So that brings us to how does the math actually read a review? Standard sentiment analysis gives you one score, positive or negative. That tells you almost nothing. Hence we use an aspect-based sentiment analysis where, for example, a guest writes the room was spotless but the pool was a letdown. We get two separate signals where we get room cleanliness as positive and pool as negative from one review. We do this across 15 aspects using our MDBERTA v3 open source model, which runs entirely on CPU, and because we use the multilingual variant, it handles over 100 languages natively. Japanese, Arabic, German, same accuracy, no extra cost. Once we have our sentiment scores, we feed these scores to our ranking engine. Our ranking engine depends on three major aspects, that is coverage deficiency, staleness and uncertainty. Coverage deficiency talks about how under-reviewed is this aspect. A value of 1 would mean that this amenity has never been mentioned and requires maximum urgency. On the other hand, staleness defines how old is this evidence, and we use time decay to model this. Uncertainty talks about how much the guest reviews disagree between each other, and we use normalized Shannon entropy to model this. Once we have all of our metrics, we take a mean of them and we rank our taxonomy based on this. Let's look at the overall picture. We have already talked about the offline pre-computation where we use the Expedia CSV to do the CSU metric computation. Coming to the online part where we read the top 3 candidates from our database and pass it to a LLM, we preferably use GPT 5.4 Nano where we pass a strict JSON schema for it to construct the questions. And once we have the reviews from the questions, we again do the offline pre-computation and write that data to our database.
So over here you can see a live product. Let's say I'm a user who wants to give a review to a property. So I would scroll down, click on write a review. Let's say I'm choosing Bell Gardens as the property. Over here I can see a brief description about the property, and I'm going to click write a review now. So I can either speak my review or type it out. So let's say I'm telling the room was spacious and I'm giving it a 4-star rating. So now this is going to trigger the question generation pipeline, and even the current open review is going to be given to it. You can see the first question which is being generated. It asks about the Wi-Fi. So let me say the Wi-Fi was great. And now the second question, which asks about whether the hotel actually provides any business facilities. So I'd say it's not, let's say it was not present, right? So I'm going to give not quite what I expected. Finally, over here you can see that how our previous two questions help answer certain aspects.
So we have another page for the vendors in which they can manage their properties and get more information. So for example, let's say that I want to look at Bell Gardens. So here we have the dashboard which has a lot of information, especially on aspects which have missing information and those aspects which are stale.
Now let's look at how we scale our system. Firstly, we use an open source lightweight NLP model which runs entirely on CPU and also offers future GPU acceleration. Secondly, the LLM only acts as a conversational interface, and that way we can handle massive review volume. And finally, the data ingestion, offline processing and the online API all are decoupled service, and hence we can scale each one of them individually. Thank you, and you can have a look at our demo at this website.